I want to at least one time walk you through the proof of the mean value theorem for integrals. So here are two theorems from Calc 1 that we will need. We have the mean value theorem, which says that if g is a function that is continuous on the closed interval ab and differentiable on the open interval ab, then there is a number c between a and b, so that g prime of c equals g of b minus g of a divided by b minus a. You might remember the interpretation of g prime of c as the slope of a tangent line, and this difference quotient as the slope of a secant line. So there's a point where the tangent line and the secant line have the same slope. The other thing we need is the fundamental theorem of calculus part 1. Suppose f is a function that is continuous on the closed interval ab, and capital F of x is defined to be the integral from a to x of f of t dt. Then capital F is continuous on the closed interval ab and is differentiable on the open interval ab, and the derivative of capital F is equal to lowercase f for all x values in the open interval ab. So suppose that f is continuous on ab, and we're going to define the function g of x to be the integral from a to x of f of t dt. Then the fundamental theorem of calculus part 1 tells us that g is continuous, I'm abbreviating, on the closed interval ab, and is differentiable, abbreviating again, on the open interval ab, and most importantly, the derivative of g is f for all x values in that interval. With that information, the mean value theorem, because g is a function that's continuous on the closed interval and differentiable on the open interval, the mean value theorem tells us that there is a number c between x values a and b, so that g prime of c is equal to g of b minus g of a divided by b minus a. That's exactly the conclusion of the mean value theorem. However, we also know from the fundamental theorem of calculus part 1 that g prime is equal to f. So g prime of c is f of c. We also know the definition of g, which is the integral from a to x. So g of b is the integral from a to b of f of t dt. G of a is the integral from a to a of f of t dt. And the bottom of the fraction is b minus a. And now, notice that the integral from a to a is really just 0. If I, instead of writing this as a large fraction, put the 1 over b minus a in front of the integral from a to b of f of t dt, we recognize the right-hand side of this equation as the average value of f on the interval ab. This gives us the mean value theorem for integrals. If f is continuous on the closed interval ab, then there's a number c in the interval ab, so the f of c equals the average value of f.